All right, good morning guys. Today we are going to be talking about multiplying polynomials. We are going to be on page 28 today. It's page 28 and multiplying polynomials. All right, and this really should be kind of a review for you guys too. We talked about this a little bit earlier when we were doing functions and function notation. So the first thing that we're going to start with is just some basic multiplying of variables. So when you multiply variables, like for instance, if you say x times x, you're not going to get 2x, but you're rather going to get x squared. So it's like saying 5 times 5 is like saying 5 squared, right? 25. So then if we want to go ahead and say something like x squared times x to the third, that's like saying x times x here, and then x times x times x here, which really is going to give us x to the 5th power. And then if we want to throw in some coefficients, we can do that as well. If we want to say like 2x squared times 3x to the 4th, we are going to go ahead and keep our coefficient here, and then it's going to be x times x. Keep our coefficient here, and then it's going to be x times x times x times x. So if you really break it down like this, you'll end up with 2 times 3, which is going to give us 6. So we're multiplying our coefficients, and then we're really just adding our exponents to get our new exponent. So x times x times x times x times x times x, that's 6 x's here, so we're going to actually end up with x to the 6th power. So that's the basics of what we're going to be talking about today. We're going to do 4 different types of examples that you're going to see on IXL. The first type of example is going to be just a distributive property problem. So you're going to see something like 3h squared, and then in parentheses you might have h squared plus 2h minus 1. All right, and so we're just going to use distributive property here. And we know distributive property is telling us to multiply. So we're going to end up with 3h squared times h squared is going to give us 3. Our coefficient stays the same. And h squared times h squared is going to give us h to the 4th power. So that'll be our first term. Second term, we're going to multiply our 3 times our 2, and we're going to get 6. And h squared times another h is going to give us h to the 3rd. And then, of course, when we just multiply this by a negative 1, we're going to actually keep this whole thing. It's just going to become a negative number. So we're going to end up with negative 3h squared. So that would be the answer to this distributive property problem. All right. So another example of this might be, you might have something like 5x being distributed to x plus 2. And again, you would just distribute 5 times 1, really, essentially. 5 times 1 is 5, so x times x is x squared, be the first term. And then 5x times 2 would just give us 10x. So you're going to see some of those problems today, probably not a whole lot. For the majority of our problems, they are going to be binomials times binomials. So if you remember back to when we were naming polynomials, a binomial just means it has 2 terms like this right here. All right, so our second example is going to be a binomial times a binomial. So what that's going to look like is x plus 3 times x minus 4. All right. Now, we talked about 2 different ways to do this when we discussed this earlier in the year. And the first way was this method called FOIL. And this stands for first, outside, inside, last. First term times first term, outside term times outside term, inside times inside, and last times last. Okay? So we can use that method. The other method we talked about was the box method, so I'm going to show you both ways again today. The box method will be down here. All right, so we're going to do FOIL first. So that tells us we're going to multiply our first times our first, so that's going to give us x squared. This is our f. Outside times outside. Excuse me. So we're going to end up with negative 4 times x. It's going to give us negative 4x. Inside times inside is going to be 3 times x. And last times last is going to be 3 times negative 4, which is going to give us negative 12. Now we do want to make sure we combine these two middle terms. Those are our alike terms. So we end up with a final answer of x squared minus 1x, or just minus x, minus 12. And that would be our final answer. Now you can also solve this using the box method. And this is the method that I think most of you will choose, but of course this is an option as well. So this was our outside, inside, last term there. All right, so our box method, you want to draw a 2 by 2 box. So it's going to look like this. And we're going to take this first one, and you can either put it on the top or on the side. It doesn't really matter. But I'm going to put my first one up top. X, and then this one has the plus 3. So each individual term has to go on a different column. Same thing for this one. Each individual term is going to go on a different row. So our first term is x, second term is negative 4. And we're going to treat this like a multiplication grid. So x times x fills in this square, and it's going to give us x squared. 3 times x fills in this square, it's going to give us 3x. X times negative 4 goes in this square, so it's going to give us negative 4x. And 3 times negative 4 goes in this square, and that'll give us negative 12. And we're going to combine the ones that are diagonal from each other, but really we're looking for those like terms. So our final answer here, again, is going to be our x squared. This one comes first. We're going to combine these. We're going to get negative x, and then we're just going to write our constant at the end. So we end up with the exact same thing, no matter which method you choose. So it's totally up to you what makes more sense to you. We're going to go a little bit more in depth here, and we're going to do a binomial times a trinomial. It's just going to extend our box a little bit more, and in this case, our FOIL method isn't really going to work. So FOIL is really only when you're doing binomial times binomial. So we're going to stick with box method for this next example. And we're going to do 3x squared plus 2x plus 4 times x minus 1. All right, so this time we're going to need a 3 by 2 box because there's 3 terms here and 2 terms here. So I'm going to make my 3 go down, my 2 go across. Again, it doesn't really matter what way you set it up. I like having more going down than across, but it's up to you. So I'm going to put my 3-term polynomial right here. So I'm going to start with 3x squared, positive 2x, and then positive 4. So I don't really need the plus signs in front there. But I am going to have to keep this negative sign in front of this 1. So it's a positive x up here, and then I do have to keep my negative 1 there. And I'm still treating this just like it is a multiplication grid. So 3x squared times x, our coefficient is going to stay the same, and we're going to end up with x to the 3rd power. 3x squared times negative 1 is going to give us negative 3x squared. 2x times x is going to give us 2x squared. 2x times negative 1 is going to give us negative 2x. X times 4 is going to give us 4x. And 4 times negative 1 gives us negative 4. Now we have to look for like terms here to start combining. So I see usually this one right here is going to be all by itself in that first box. So that's going to be our leading term. 3x to the 3rd power. And typically what we can say is that our diagonals are going to be our like terms. Okay, not always the case, but most of the time that's going to be the case. So we're adding here. We're not multiplying anymore. We're just simply combining like terms. So if 2x squared minus 3x squared, which is going to give us a negative 1x squared, or just negative x squared. 4x minus 2x is just going to give us a plus 2x. And then we keep our negative 4 at the end. This one would be our final answer. The last type of example that we're going to talk about today is where you have a polynomial that is being squared. So if you have something that looks like this, then you can't just take this square and distribute it in. It's not going to work that way. You actually have to think about what that square means, and it means that we're taking this x plus 3 and multiplying it by itself. So it's actually going to translate into looking like this. And once you do that, then it becomes just like example number 2. So you're just multiplying those two binomials out. So again, here you can choose either the FOIL method or the box method, your choice. I like to use the box method because it does work for all different types of multiplication of polynomials. So I'm going to make a 2 by 2. I'm going to put x and positive 3 here, and x and positive 3 here. So treat it like a multiplication grid. X times x is x squared. X times 3, 3x. X times 3, 3x. And 3 times 3, 9. We want to combine our like terms by adding the diagonals. So this is going to be our leading term, x squared. 3x plus 3x is going to give us a positive 6x. And we add our 9 at the end. And that is really all we are going to be focused on today.